In all, 9 questions were given from the section Functions from the chapter Differential Calculus in the JEE Main January 2024 session. We have already covered questions 1 to 3 in an earlier video. We will now discuss the questions 4 to 6 from the functions from the chapter Differential Calculus now. This question has appeared in the JEE Main exam held on 30th January 2024 in the first shift. The given question is, let A be the set consisting of the elements 1, 2, 3 up to 7 and P of A denote the power set of A. We are given a set A. This is the set consisting of 1, 2, 3 up to 7 and P of A will represent the power set of A. That means the set of all subsets of A. Right. If the number of functions f from A to power set of A such that element A belongs to f of A for all A belongs to A is m power n, that is, if the number of these functions is m power n, where m and n are natural numbers and m is the least, then m plus n is equal to. So, we are considering the number of functions f from A to power set of A such that A, the element A belongs to f of A for all A belongs to A. Such functions, the number of such functions is m power n, where m and n are natural numbers and m is the least and required to find the value of m plus n. Let's now discuss the solution of this problem in detail. Right. We have A is equal to the set consisting of the elements, the numbers, natural numbers 1, 2, 3 up to 7 and P of A represents the power set of A, that is the set of all subsets of A. Right. Let's now consider yes, the set of all those functions f from A to power set of A, where A belongs to f of A for all A belongs to A, where f of A is an element of power set of A, that is a subset of A containing A, because A belongs to f of A. F of A is an element of power set of A, that means it is a subset of A, and A belongs to f of A means f of A is a subset of A containing A. Agreed. So, this means the set of all functions f from A to power set of A such that the element 1 belongs to f of 1. F of 1 is a subset of A containing 1. 2 belongs to f of 2. F of 2 is a subset of A containing 2 and 7 etc. 7 belongs to f of 7. Agreed. And why we are considering S the set of all those functions? Because we want to count the number of elements in S. Right. So that means required to find n of S. So that's our goal. Right. Now let A suffix I be the set of all subsets of A containing the element I belongs to A. Agreed. So that means the above one can be written as S is equal to the set of all those functions f from A to the power set of A such that 1 belongs to f of 1. F of 1 means A1. So AI is the set of all subsets of A containing I belongs to A. So A1 will be the set of all subsets of A containing 1 belongs to n. Then 1 belongs to f of 1. That is 1 belongs to A1, 2 belongs to A2, 7 belongs to A7. That means how this function f is materialized? how this function f is materialized. This is materialized corresponding to an element of A1 and corresponding to an element of A2, corresponding to an element of A7. All these, one element from A1, one element from A2, one element, etc., one element from A7 will determine one function, and conversely. So corresponding to each function, you will find a subset of from A1 and a subset from A2, a subset from A7, etc. That is, note that each function is a choice of one element from A1, one element from A2, one element from A7, etc. And conversely, corresponding to one element from each of A1, A2, A7 will determine a function f. That is, in other words, that is, corresponding to each function f belongs to S, we have an element of A1 cross A2 cross A3 cross A4, etc., etc., cross A7. This is the Cartesian product, and conversely. And what does it mean? These two statements mean. That means corresponding to each f belongs to S, there is an element of this one, this cross product. And conversely, corresponding to an element of the cross product, we have a function f. Corresponding to each f belongs to S, we have an element of this cross product. And corresponding to each element of the cross product, there is a function f. That means you are setting up a bijection between the functions f belongs to S and the elements of this cross product. It's a bijection. Therefore, n of S is equal to n of A1 cross A2 cross A7. So this is the one because of the bijection. So n of A1 cross A2 cross A3 cross A4 cross A5 cross A6 cross A7. Use the product rule of counting. Then you will get n of A1 multiplied by n of A2 multiplied by n of A3, etc., multiplied by n of A7 by the product rule of counting. Let's call this equation as number 1, and we go to the next slide for the further discussion. Yes, that's what we have done so far. So that is the equation 1. Now let us count how many elements are there in A1. What is A1? A1 is set of all subsets of A containing 1 belongs to A. How many are there? So now n of A1 is equal to number of subsets of A containing 1. To count this one, first of all, let's count the number of subsets of the whole set A, that is 1, 2, 3 up to 7. These are 7 elements. Number of subsets will be 2 power 7. Agreed. Minus, consider the set not containing, consider the set 2, 3, 4, 5, 6, 7. That means A, they take the set A and subtract, that is minus the singleton one, A minus singleton one. That means the set consisting of 2, 3, 4 up to 7. So you say the number of subsets of this 2, 3, 4, 5, 6, 7 you subtract. That is total number of subsets of A minus the number of subsets of A not containing 1. Not containing 1 means A minus the singleton 1. So this is n of power set of A minus n of the power set of A minus singleton 1. That is, the A minus singleton 1 is 2, 3, 4, 5, 6, 7. How many? 6 in number. So this is 2 power 7. This is 2 power 6. And 2 power 6 taken common, then you'll get 2 minus 1 multiplied by, and 2 power 6 into 1, that is 2 power 6. A n of A1 is 2 power 6. The same argument is valid even for n of a2, n of a3, so on and so forth. Similarly, we will get n of a2 is equal to n of a3 is equal to etc. n of a7 is equal to 2 power 6. Now let's go back to the equation 1. Therefore, n of s is equal to n of a1 multiplied by n of a2 etc. n of a7 from the equation 1. So the each one is 2 power 6. So this is equal to 2 power 6 multiplied by 2 power 6 multiplied by 2 power 6 etc. 2 power 6 and 7 times. That will be 2 power 6 to the power of 7. That is 2 to the power of 6 7 are 42. That is given to be m power n. So m will be 2, n will be 42. Required to find the value of m plus n. Right. The answer is m plus n is equal to m is 2, n is 42, the total is 44. So that is the answer. The answer for m plus n is 44. That is the detailed discussion of the solution of this problem, and I am sure that you have understood the solution of this. Let's now move to the next question. This question has appeared in the JEE Main exam held on 30th January 2024 in the first shift. The given question is, if the domain of the function f of x is equal to cos inverse of 2 minus mod x by 4 plus log of 3 minus x to the base e to the power of minus 1, that is 1 by log of 3 minus x to the base e. So right. So required to find the domain of this function, and it is given, it is the semi-closed interval minus alpha to beta, it is closed at minus alpha n minus singleton gamma. Then you are required to answer alpha plus beta plus gamma. Right. So you are given this function, you have to and it is given to us the domain of this function is the semi-closed interval alpha to beta minus singleton gamma, and required to find the value of alpha plus beta plus gamma. We are given 4 options. Let's now move to the solution in detail. Right. We have this function and required to find the domain of fx. And recall, it is f of x is equal to g of x plus h of x. And how do we find the domain of f of x? The domain of f of x is equal to domain of g of x intersection with the domain of h of x. So the domain of f of x is equal to the domain of the first function intersection the domain of the second function. Agreed. Let's now first take up domain of the first function. The domain of cos inverse of 2 minus mod x by 4. What is the domain of cos inverse? The domain of cos inverse is minus 1 less than or equal to 2 minus mod x by 4 less than or equal to 1. So the domain will be the set of all those real numbers x which satisfy this inequality. Agreed. Agreed. And now let us now see what is minus 1 less than or equal to 2 minus mod x by 4 less than or equal to 1. Multiply throughout by 4. Don't worry. The inequality is not get disturbed because 4 is positive. So you'll get this one. Now subtract 2 throughout. Then you'll get minus 6 less than or equal to minus mod x less than or equal to 2. Multiply throughout by minus 1. Yes. The inequalities get, interchanged. So then it will be minus 2 less than or equal to mod x less than or equal to 6. You are multiplying by minus 2. Therefore, the inequality is reverses. So, and mod 2 less than or equal to mod x is not possible. This is because mod x is non-negative. Therefore, it should be mod x less than or equal to 6. That means minus 6 less than or equal to x less than or equal to 6. That means x belongs to the closed interval minus 6 to 6. So let's go back. So the domain of cos inverse, this one, is minus 6 2 plus 6. Closed interval. Agreed. Now let's go for the domain of log of 3 minus x to the power of minus 1. What is this function? This is 1 by log of 3 minus x. Now 1 by log of 3 minus x, the domain will be x belongs to R such that 3 minus x not equal to 1. If 3 minus x is equal to 1, it will be log 1 is 0 and 1 by log 1 is undefined. That is why 3 minus x not equal to 1. And logarithm is defined only for positive values, that is 3 minus x greater than 0 and. So that means it is the set of all x belongs to R such that 3 minus x not equal to 1 intersection with the set of all x belongs to R such that 3 minus x greater than 0. That is, this is the set of all x belongs to R. 3 minus x not equal to 1 is x not equal to 2. That means it is a singleton set consisting of, it is R minus set of all real numbers other than 2. That means R minus singleton 2 intersection. 3 minus x greater than 0 means x less than 3. That means it is minus infinity to 3. So this is R minus singleton 2 intersection minus infinity to 3. Minus infinity to 3. Now you see the intersection of R with minus infinity to 3 is minus infinity to 3 only, because this is a part of R. Minus infinity to 3 intersection singleton 2 is only singleton 2. So it is this one, minus infinity to 3 open interval minus singleton 2. Agreed. Now let's now go back. The domain of fx will be domain of the first function, cos inverse function, that is minus 6 to 6 intersection with the domain of the second function is minus infinity to 3 minus singleton 2, closed open interval. Right. Take the intersection. Minus 6 to 6 intersection with minus infinity to 3. What is common? Minus 6 to 3. Minus 6 to 3. Minus 6 is included. 3 is not included. So minus 6 to 3. Minus 6 is included. 3 is not included because of the intersection of this with this. And minus 6 to 6 intersection with 2, the common is only 2. Therefore, this is this semi-closed interval minus singleton 2. This is given to be the semi-closed interval minus alpha to beta minus singleton gamma. So, comparing, alpha will be 6, beta will be 3, gamma is equal to 2. Right. What is to be found? Now, required to find alpha plus beta plus gamma. That is 6 plus 3 plus 2, that is 11. Let's look at our options. Our answer 11 appears against option 2. Therefore, the answer to this question is option 2. And that is the detailed discussion of this solution. Let's move to the next question. This question has appeared in the JEE Main exam held on 30th January 2024 in the second shift. The given question is, if the domain of the function f of x is equal to log of is a quotient 2x plus 3 by 4x square plus x minus 3 to the base e plus cos inverse of 2x minus 1 by x plus 2. So, we are given fx and you have to find the domain of this function. And the domain of this function is given to be the semi-closed interval alpha to beta closed at beta n. Then the required to find the value of 5 beta minus 4 alpha. And we are given 4 options. So, you have to find the domain of this function and you are given that domain is the semi-closed interval alpha to beta, then find alpha, beta, and find 5 beta minus 4 alpha from these 4 options. Let's now discuss the solution of this problem in detail. Agreed. We have the function f of x as given above. First is the logarithm plus cos inverse of. Right. And the domain of f of x is equal to the domain of the first function intersection the domain of the second function. Right. Let's call this as the equation 1. So let's take first of all the domain of the first function. The domain of log of 2x plus 3 by 4x square plus x minus 3 to the base e. That's equal to the set of all those x belongs to R, and the value of log 2 exists. This 2x plus 3 by 4x square minus x minus 3 must be greater than 0. Then only log exists. So that's equal to the set of all those x belongs to R such that 2x plus 3 by the factors for the denominator are 4x minus 3 into x plus 1 greater than 0. Right. 2x plus 3 is equal to 0 will give you minus 3 by 2. 4x minus 3 is equal to 0 will give you 3 by 4. X plus 1 is equal to 0 will give you minus 1. Order them. If you order them on the real numbered line, it is minus 3 by 2, then comes minus 1, then comes 3 by 4. Right. Now suppose you take x greater than 3 by 4. X greater than 3 by 4. That means to the right of 3 by 4, any element if you take it, then 4x minus 3 is positive, and x greater than 3 by 4, then x plus 1 is positive, 2x plus 3 is positive, positive by positive is positive. So when x comes to the right of, from the right of 3 by 4, it is positive. Once you say it is positive, this is negative. That means when x comes from the interval minus 1 to 3 by 4, negative, and then positive in this interval, and then negative in this interval, minus infinity to minus 3 by 2. But if you want what? You want the positive ones, So this will be minus 3 by 2 to minus 1, minus 3 by 2 to minus 1. Agreed. Minus 3 by 2 to minus 1, open interval, and this interval 3 by 4 to infinity. It is greater than 0. That is why the open intervals are coming. Right. This is the union of these two open intervals. We got it. Let's now move. Consider the second function and consider its domain. Right. The domain of cos inverse of 2x minus 1 by x plus 2 is the set of all x belongs to R such that the domain of cos inverse is minus 1 less than or equal to 2x minus 1 by x plus 2 less than or equal to 1. Right. Let's now break this one inequality. X belongs to R such that minus 1 less than or equal to 2x minus 1 by x plus 2 and 2x minus 1 by x plus 2 less than or equal to 1. Agreed. This is the set of all those x belongs to R such that 2x minus 1 plus by x plus 2 plus 1 is greater than or equal to 0. Yes. Greater than or equal to 0. And 2x minus 1 by x plus 2 minus 1 is less than or equal to 0. Because this is the end, the intersection, you have to consider x belongs to R such that 2x minus 1 by x plus 2 plus 1 is greater than or equal to 0. Intersection with the set of all those x belongs to R such that 2x minus 1 by x plus 2 minus 1 is less than or equal to 0. Right. Let's first of all consider this on the real numbered line. Now for that, you have to consider 1 by 2 and minus 2. So real numbered, and take the LCM. I'm sorry. Take the LCM. If you take the LCM, it will be 3x plus 1 by x plus 2 greater than or equal to 0. Take the LCM here. It is x minus 3 by x plus 2 less than or equal to 0. Right. So 3x plus 1 means you have to consider minus 1 by 3. X is equal to minus 2 you have to consider. So this is the real number line. We will come first minus 2 and then minus 1 by 3. Right. Suppose you take x to the right of minus 1 by 3. That means x greater than minus 1 by 3. Then 3x plus 1 by 1 is greater than 0. And x plus 2 is obviously greater than 0 because minus 1 plus 3 minus 1 by 3 plus 2 is positive. So it is positive. Then obviously it is negative in this interval. And in this interval, minus infinity to minus 2, it is positive. And here, what you want is greater than or equal to 0. That means you have to write down these intervals. But appropriately you have to write down, and I will tell you when I was talking about this one. Let's now get into the second one. So you have to consider 3 and minus 2. Who will come first? Minus 2. Minus 2 and 3. Right. When x is greater than 3, from here, x minus 3 is greater than 0 and x plus 2 is also greater than 0. It will be greater than 0. That means positive. Obviously, this will be negative and this will be positive. And here you have to consider less than or equal to 0. That means in this you have to consider. So let's now get into the first one. So the positive ones you have to consider. So minus infinity to minus 2. Is it closed or open? Minus infinity to minus 2. Why? Why not minus 2 closed? If you take x is equal to minus 2, put it here, then it will be infinity. And that means 1 by 0 is undefined. Therefore, it's open. But whereas minus 1 by 3 to infinity, minus 1 by 3 is included. Why? Even if you take x is equal to minus 1 by 3, it is equal to 0, and in this inequality greater is equal to 0 is also included. Therefore, it is the semi-closed interval minus 1 by 3 to infinity intersection. This negative portion you have to consider. Minus 2 to 3 semi-closed, closed at 3 end. Now you will ask a question, why minus 2 is not closed? If it is closed, x is equal to minus 2 is included, that means the denominator becomes 0. So this is undefined. Therefore it's open. But whereas x is equal to 3 you can consider, and x is equal to 3, the answer, one of the answers will be equal to 0. Therefore you have to consider that. Therefore it's included. Now let's take the intersection. So A union B intersection C will be A intersection C union B intersection C. If you take minus infinity to minus 2, intersection minus 2 to 3, they are disjoint because minus 2 is not common because it's open. Therefore, they are disjoint. Therefore, empty, that is 5, union this one. That means the second intersection minus 2 to 3. Now, it is minus 1 by 3 to infinity, intersection minus 2 to 3. Now, what is common? Minus 2 is very far off, then minus 3 comes, then 3 comes, then infinity comes. What is common? Well, the common is minus 1 by 3 to 3. Minus 1 by 3 to 3. The smaller ones. Minus 1 by 3 to 3. So that is the domain of cos inverse. Now we will go and take the intersection with the domain of the first function, logarithm of. Right. So the domain of the given function, domain of logarithm, the logarithm of 2x plus 3 by 4x square plus x minus 3 to the base e is the union of these two intervals. Domain of cos inverse of 2x minus 1 by x plus 2 is this interval. Right. So domain of the given function will be the intersection of these two. So it is minus 3 by 2 to minus 1 union 3 by 4 to infinity, and this is minus 1 by 3 to 3, minus 1 by 3 to 3 if you take it, and the intersection of the first minus 3 by 2 minus 1 intersection with minus 1 by 3 to 3, they are disjoint, is empty. So the intersection is practically 3 by 4 to infinity, open interval, intersection with this interval. So this is the one. Take the intersection. So minus 1 by 3 comes first, then 3 by 4, then 3, then infinity. What is common? 3 by 4 is open to 3 closed. It's a closed interval. But this is given to be alpha comma beta, like this, the same type of interval. So therefore comparison, alpha is equal to 3 by 4, beta is equal to 3. Therefore we have to find 5 beta minus 4 alpha. That is 5 into beta is 3 minus 4 into alpha is 3 by 4. That is 5 3s are 15 minus 3, and that is equal to 12. So the answer given is against option 4. Therefore the answer to this question is given in option 4, and that is the detailed discussion of the solutions of the problems numbers 4, 5, 6 from the section functions from the chapter Differential Calculus, which are given in the JEE Main January 2024 session. I am sure that you have understood the solution of these 3 questions, and I wish you all the best. Thank you.